Once you have the polynomial function has the constant once your polynomial function has all integer coefficient, then we can find all possible rational zero. So all possible rational zeros. Now up here you are looking for all possible rational zeros. You are not solving for it yet. You're just finding the starting point. How do we find a factor to break down this function? So we call all possible rational zeros. Now, all possible rational zeros, they are from your P over Q. P is the all factor of your constant term. So the constant number has 18. So we start from 1. We are going to have a lot of factor on the numerator. 2, 3, 6, 9, and 18. They are all factor of the number 18. Q is the all factor of the leading coefficient term. So this is 3. So all factor will be 1 and 3. And then from here, you select all possible selection, right? So you have 1, you have positive negative 1, positive negative 1/3. So let me write down here, you have positive negative 1. I'm going to put both signs together. Positive negative 1/3. Positive negative 2. Positive negative 2/3. Positive negative 3. And positive negative 1, right? Because 3 divided by 3 is 1. So 1 was here. No, then you don't write them twice. We move on to 6. 6 divided by 1, you have positive negative 6. 6 divided by 3 is 2. 2 was here. Now we move on to the next one. 9 divided by 1, you will get a positive negative 9. 9 divided by 3 again is 3. So 3 was here. 18 divided by 1, we'll get 18. 18 divided by 3 is 6. 6 was here. So you don't represent them twice. So all the possible rational zeros they are here. And this is a way you're getting all possible rational zeros. Now we move on to the next one. We move on to finding the rational zeros. So finding the rational zeros, that means we are solving for x. Solving for x, which means we are finding the root, solving for the root, right? Or finding for the zeros. They are all represent the same meaning. You are solving for your x. So we look at the example. And before the example, here has at least 4. Alright, this is a typo. This should be 4. So 4 procedure or instruction you can follow it when you break down the polynomial function into pieces. The first step will be use the zero theorem, rational zero theorem, to list all possible rational zeros. So that means you need to find possible rational zeros. I like to use all possible rational zeros. Once you have all possible rational zeros ready, you go with the remainder zero theorem to finding the root. That means you pick a possible rational zero from all the list there. Like say you pick a 1. So you substitute 1 into the function. We are looking for the output is 0. If you get a 0, then that means this is a root of the polynomial function. Then from there, we use the root to break down the function by using the syntactic division to depress the function. If you have more than zeros, you repeat the previous step. Just repeat the process, finding the all possible rational zeros, getting the root and the zero theorem, and then break down that part of the function by using the syntactic division. We do the example, then you'll understand what I'm saying here. Finding the rational zeros. Keep in mind, you are solving for x with this one, alright? Rational zeros. So function p is a polynomial function. So since the polynomial function, we know the solution of the x, we should have 3 solutions because the highest degree power is 3. So you should have 3 zeros or 3 roots, right? 3 roots or 3 solutions, they are all the same meaning. So now, how do we start from the step 1, finding the all possible rational zeros. So it's coming from p over q. Now p is all possible factor of your constant term. So the constant number is 3. So we know the possible factor would be 1 and 3. Over your q is all factor of the leading coefficient number 2. So the factor would be 1 and a 2. Now we cleaned up the selection here. So the all possible rational zero for function p of x would be 1, right? 1 divided by 1, you get a 1. 1 divided by 2, you get a half. 3 divided by 1, we get a 3. 3 divided by 2, you get a 3 over 2. So now we have all possible rational zero here ready. Now we want to use the remainder zero theorem to finding the starting point to break down our function. And most of the time, I start from 1 because that's an easier number we start with. So the idea is I pick the 1. Right? If 1 doesn't work, you move to -1. If both of number doesn't work, you move to the positive half and then just continue to try each of the number until you get a 0. So when I have the 1 plugging to the function, we will have 2 multiplied by 1 power 3 plus 3 multiplied by 1 over power 2 minus a multiplied by 1 plus 3. When I do the calculation, it gives me the 0. So that means 1 is a root. This is a root of the polynomial. So that means 1 is the solution of this function. Now, since I know the 1 is the solution of the function, that means I can use the syntactic division to break down the function or to depress the function into different pieces. So using the syntactic division, we only take the number term, right? So we have 2, this is 2x power 3, 3x squared, -8, and a 3. Now the outside box here, we fill in the root. Okay, let me erase here. Let me redraw the box. Okay. Now the root outside. When the number is a root, you just simply to copy down the root number into here. If the question gives you the factor form, +1, that means the root of this one is x equals -1. So this is a root, right? And this is a factor form. The number, they are opposite. So we just fill in the 1 here. Now we do the syntactic division. Drop down the 2. 2 multiply 1, you get a 2. Sum these 2, you get a 5. 5 multiply with 1, you get a 5. Sum these 2, you get a -3. -3 times multiply with 1 is -3. And 3 plus -3, you get a 0. So this is the remainder. Now these 3, they represent the constant term, x term, x squared term. So if I reorganize the function of p of x, 1 is a root, right? So when I reflect the root back to the factor form, I should have x minus 1. because that's the only way you can get the root is 1. Another pieces of the polynomial function would be 2x squared plus 5x minus 3. Once you multiply these two, it will go back to the polynomial function itself. Okay? So now, these pieces, we have quadratic function. To solve for this part of the quadratic function, put on the side here. When we have the trinomial, finding the factor form, because the leading coefficient is not 1, so I show you all swing this number to the back. Now you'll have that x squared plus 5x minus 6. Then from here, it's very easy to finding the factor form, right? So we'll have x and x. Two numbers multiply, you can get a 6. Sum those two, you'll get a 5. Is 2 and 3. However, the middle term is a positive 5. So if only way I can get a positive 5 is plus 2 plus 3, right? But when you multiply the last two terms, when you multiply 2 and 3, both of terms carry the positive sign. There's no way you'll get a negative 6. So 2 and 3 is not the right option. So we have to try 1 and 6, right? 1 and 6 is another way you can find. You can get a sum is 5 and the product is negative 6. So since the middle term is 5, positive 5, that means the bigger number is a plus, small number is a negative. Once you have the factor form here ready, do not forget to swim these two back. And the way we swim the two back, we divide by 2 only under the number term. And then you reduce first. 1/2 1 over 2 you cannot reduce, so we swim these two back to the front. So your factor form of the trinomial here was 2x minus 1 multiply x plus 3, and there was x minus 1 here. So this is the way we break down the polynomial function into 3 pieces, all right? We break down the polynomial function into the single factor form. The reason why we have to do that, because this is the only way we can solve for the single x. So we solve for x equal 1. From here, we solve for x equal 1/2. From here, we solve for x equal 3. So you have the 3 solutions or 3 zeros of your polynomial function.